Hello everyone, welcome to MBBS Atlas, and in this video we'll be discussing the properties of cardiac muscle. So the cardiac muscle, it possesses characteristic features which are absent in other muscles, okay, because it is a specialized muscle. So in this video we'll be discussing the properties which are present in the cardiac muscle and which are very much important, okay. The first property we need to discuss is the rhythmicity. So what is rhythmicity? So, rhythmicity is nothing but the cardiac muscle, it possesses the property of beating rhythmically, that is automatically. So, this is called as autorhythmicity. Not only it is automatic but also it is rhythmic. That means the lub and dub. Okay, lub dub. These two are the sounds that we get to hear in the heart, right? So, these two sounds which are produced are rhythmic. Okay, they are having contraction of ventricles leads to this rhythmicity. Now, this property, rhythmicity along with automaticity, it is called as autorhythmicity. Okay, so what is the reason for this rhythmicity to be produced? So, this rhythmicity it is produced because of presence of SA node. Okay, this SA node it is responsible for the production of rhythmicity, autorhythmicity. How? So there is a saying that SA node is called as the primary pacemaker. Why it is called as a primary pacemaker? So this can be asked as a reasoning question. So the SA node excitation begins at the SA node. Okay, what is excitation? So for the heart to beat, to pump the blood, there needs an stimuli. That stimuli is the excitation. That stimuli is initiated from the SA node which is present in the heart. This SA node it causes the initiation of stimuli, that is the excitation begins at the SA node and the rate of discharge of SA node is 60 to 100 beats per minute. This discharge is equal to heart rate. So in a normal individual the heart rate is equal to the discharge of SA node. The amount of stimuli or the amount of excitation that SA node discharges is equal to heart rate in normal individuals. That's why it is said that it is about 60 to 100 beats per minute, that is equal to heartbeat, normal heartbeat. Okay, that is a range. Now, if in case SA node fails to discharge the stimuli, or if the SA node fails to excite, then what is the condition of heart? So will the person die? No, the person will not die. There are some other pacemakers in the heart that can replace SA node if it is non-functional. What are those? Those are AV node, bundle of His, and Purkinje fibers. Okay, so what is this other pacemakers? These are called as secondary pacemakers. So when will they get activated? Whenever the SA node is not functional, if it is not working, if it is not able to discharge the stimuli at that time, these pacemakers come into action. So what do they cause? So these pacemakers they are responsible for conducting the stimuli. But what is the speciality? What is the uniqueness of SA node? Is that it is the only stimuli, it is the only node that can initiate the heartbeat with highest frequency. Okay, with highest frequency, it can initiate the discharge. That is the reason why it is said to be the primary pacemaker, and it triggers the action potential which propagates throughout the heart. This is why it is called as the primary pacemaker. So it is responsible for initiating the stimuli, initiating the discharge, and it is also responsible for stimulating the action potential with highest frequency. Okay, so these are the two functions of SA node that we need to remember. Now, if an SA node fails to initiate the heartbeat, then AV node, bundle of His, Purkinje fibers, all this can initiate heartbeat. So these are called as secondary pacemakers, which are functional when the SA node is non-functional. Now the second property that we get to see is the conductivity. Now what is conductivity? The name itself indicates that it conducts the whatever impulses are discharged from the SA node. So whatever stimuli or the discharge that is initiated from the SA node is conducted through the conducting system of heart. Okay, so that is the property of the conduction is called as conductivity. So the impulses initiated by the SA node follows a specialized conductivity pathway. Now what is that pathway? First impulse initiated by the SA node reaches the AV node. From the AV node, it reaches the bundle of His. From bundle of his, it reaches the right and left bundle fibers, and ultimately it reaches the Purkinje fibers, which supply throughout the heart. So this is the pathway for the conducting system of heart. The next property of the heart is contractility. What is contractility? The ability of the heart to respond to the stimuli generated by the SA node and being able to contract is called as contractility. So heart contracts automatically and rhythmically in response to the impulses generated by SA node. So whatever impulses the SA node generates in response to the stimuli, it is contracting. That ability of the heart to contract is called as contractility. Now, we need to remember a relation that the force of contraction is directly proportional to cardiac output. So, this is the Frank-Starling law. Okay, this is the Frank-Starling law which we'll discuss, which I've discussed in the cardiac output. Now, the another thing that we need to remember here is that the Vmax or the velocity is the measure of contractility of myocardium. Okay, so this can be asked as an MCQ question. The another property is the excitability. This excitability and contractility properties are related to each other. How? So the SA node it discharges the stimuli, right? So the ability of the heart to respond to the stimuli is what we call it as excitability. If the heart is able to receive the stimuli and it is responding to the stimuli, it is getting excited, right? So the ability of the heart is called as excitability. So if the heart is excitable, then only it can contract. So this contractility of the heart is dependent on the excitability of the heart. Okay. So the heart muscle is an excitable tissue like nerve and other muscles. Okay. Nerves and other muscles are also excitable. The ability of the heart to contract depends on the excitability. Okay. The next property that we get to see is the long refractory period. Now, this is a very important property, that is the long refractory period. Let us understand this. So, there is another reasoning question which might be framed from this topic, that is, why cardiac muscle cannot be tetanized? What do you mean by tetanized? Cardiac muscle tetanization means being in a continuous contracted state. Okay, being in a continuous contracted state is what we call it as tetanized. But cardiac muscle cannot be tetanized. So we know very well that the heart always contracts, relaxes, and this is very simultaneous and rhythmic. What is the reason behind this property? Let us understand this by comparing it with skeletal muscle. Okay, now what happens in the skeletal muscle? So in the skeletal muscle, let us suppose, let us assume this to be the red line to be action potential. Okay, and this green line to be contracted state. Okay, now what happens in the skeletal muscle is that the action potential is just for few milliseconds, whereas the contraction is last for more time. Okay, in skeletal muscle the action potential is for lesser time, in that is few milliseconds, whereas the contraction lasts much longer. That's why whenever the stimuli falls in this time, during this time when the contraction occurs, at that when the action potential is not present but the contraction occurs, at that time there is summation of stimuli, and the summation of the contraction can lead to tetany. Okay, this is the summation of contraction can lead to tetanus of the heart. That means the heart remains in the continuous contracted state. This is the reason why in the skeletal muscle the spasm, we get to see the muscle spasms, whereas in the cardiac muscle tetanization is not possible because of this reason. Now, what happens in the cardiac muscle? The action potential and the contracted state, they coincide with each other. Okay, they coincide with each other. That is the reason why the even when there is stimuli occurring during this phase, there is no contraction because there is no summation. Remember one thing, that whenever there is action potential, at that time the summation cannot occur. The heart cannot respond to the stimuli during the action potential. Because the action potential in skeletal muscle is for lesser time and the contraction is for more time, there is a chance for the stimuli to undergo summation. That's why there is summation occurs, and that leads to tetany. Whereas in cardiac muscle there is no the action potential is equal to the contraction state, there is no chance for the summation to occur, and that is why there is no muscle spasm or tetany. Okay, and this is called as the long refractory period. So the heart has the long refractory period, that is why it doesn't undergo tetany, whereas the skeletal muscle has short refractory period, that's why it undergoes muscle spasm. So this is the image of action potential of cardiac muscle. So we can observe here that it is having a large action potential compared to skeletal muscle, and that is the reason why it does not undergo muscle spasm or tetany. The next property is the all or none law. What does this property say? The magnitude of response of the tissue to the stimuli will be same irrespective of the strength of the stimuli. That means if the tissue responds, it responds completely or it does not respond at all. So there is no like subthreshold, or if you give lesser stimuli it will respond with a lesser intensity, or if you give more stimuli the heart will respond with more intensity. This doesn't occur. Okay, if you give stimulus more than the threshold stimulus, at that time only the contraction will occur. If you give more stimulus there is more contraction, if you give less stimulus there is less contraction. That does not occur. That is what the law is explaining. This is the image depicting the all or none law. So if you observe this one, this is nothing but the subthreshold stimulus. So the subthreshold stimulus, it is not giving any excitation. We can observe here it is a very straight line. Whereas this is the 2 is the threshold stimulus. At that time only the excitation can occur. Okay, here we need to remember that the subthreshold stimulus does not give any response. Okay, this is what we need to remember. Only threshold stimulus can give the response. Okay, below or above that it does not cause any contraction. Okay, so whenever the stimuli reaches the threshold stimulus, at that time only the contraction of the heart can occur. That is all what the law says. The last property of the cardiac muscle is the staircase phenomena. What does this staircase phenomena say? If the heart is repeatedly stimulated in span of 10 seconds, the magnitude of first 3 to 4 contractions progressively increases. So this is an experiment that is done on the heart's frog. Okay, frog's heart. Sorry. So in this experiment, what we need to do is when you give continuous stimuli for about 10 seconds, after first 3 to 4 contractions, the rest of the contractions progressively increases. Okay, this is called as staircase phenomena because it looks like a staircase, it is progressively increasing, right? So because it looks like a staircase, that's why the phenomenon, the name is given as staircase phenomena. Okay, so this is all about the properties of cardiac muscle. I hope this is clear, and thank you for watching this video.